Alright, today we have our pre-calc P1 notes. Your P1 notes you should have been filling in from your textbook. You'll be able to graph these points, find the coordinates, be able to label axes, being able to translate, which means move from one to the other. All this stuff is on page 2. This description of this transformation, really pay attention on page 3. At the bottom of page 3, it's going to talk about a transformed point if you take the negative of x, negative y, or negative of both points. If you flip the page 2, the next part of it talks about your graphs. What kind of different graphs do we have? We have a scatter plot, a bar graph, and then a line graph. One thing you want to make sure of is that the broken horizontal. So like those are broken because they have those little squiggly marks. When we get to our graphing calculator practice, we have a word problem here that allows for the population in North Carolina can be modeled by this equation, where x is in times of years, where x equals 0 corresponds to 1990. So 1 represents 1991, and so on. It says we're going to enter the list in a graphing calculator and find when the population exceeds 7 million. There's going to be several ways that we are going to do this. So first of all, let's get the graphing calculator. And on our graphing calculator, we want to make sure everything is cleared out. The best way is to reset the memory on your calculator, especially if you haven't used it from last year. So second, and then the plus sign will get you to your memory. We want option number 7, where we're going to reset it. We want all of it, number 1, and number 2, reset. And now it tells us that we have cleared that all. We're going to start by plugging in the equation that is given, y equals, and we're going to put that y equals into our y equals equation. So y equals 0.11x plus 6.63. We can graph this, and we see part of the line. Now our list that we're looking at are only of the years from 1990, 91 up to 97, so we might want to change our window. And when we change our window, what it is that we are looking at here, under window, we want to start with 0, and we can go up to 10, that's fine, by ones. The minimum, we don't care about negative population, just like we don't care about negative years, so we're going to go 0. And we're going to go maybe up to 10 by 1, and we'll just see what that gives us when we graph it. Sometimes you got to play around with your windows just to see what might be there. Alright, so this gives us a line. So this is one way that we have looked at it. We have put our information in y equals. We put the y equals equation in. Then we have graphed it, and we've looked at our window. This information, what does the value of 0 give us? We have several ways to be able to find that. One of the ways that we can use is this table function, which is above the graph key. So in order to get to that, we have to hit our second button. So we're going to hit second and table. Notice here are our x values, 0, 1, 2, 3, 4, 5, 6, and you can keep arrowing down to get to 7. And those are the corresponding y values. Oops, let's see, let's go over so that we can get to those. So we can fill this in just from being able to put in our y equals and go to our table. So for example, this is going to be 6 at 0, sorry, we want 0. I want to clear that. There's 0. So 6.63. 1 is 6.74. 6.85. And I can go and I can fill in the rest of them. But that's just one way to do it. Let's look at another way. Here's our other way. Enter the x values into list 1 into the graphing calculator, and enter the formula into list 2. So under your list, the way we get to that is the stat key right above it is the word list. So second list, and that's where all of our information is. We can do some different things with that. We can sort them, we can math them, but we actually need to input it. So if we're going to enter values into list 1, you actually go to stat and edit. So here's our stat key. The very first one is edit, and there is list 1. List 1 is actually going to be our x values. So we're going to put in 0, enter 1, 2, up to 7. Okay. Then we're going to arrow over to list 2. It says enter the formula into list 2. So that's going to be our equation, 0.11 x plus 6.63. Now here's the catch though. X is really L1. So when I plug this in, I'm really going to put 0.11 L1 plus 6.63. So let's pull a calculator here, and we're going to go 0.11 L1. So that's second and 1, because if you look here, L1 is above the 1. So hit your second key and L1. So now this says 0.11 times my x values, and the x values are list 1, plus 6.63. Oops, let's see what we got here. I must have typed something in wrong. Oh, sorry. You have to actually be up on L2. Oops, go to it. We're going to clear that. You have to be up here, sorry, on L2, because we're putting an equation in. We're not putting data. An equation. 0.11, shift L1, so second L1, plus 6.63. So 0.1111 times the x values plus 6.63, hit enter, and there we go. Notice the values that are coming up in list 2 are the same exact y values that we got when we graphed the table. We can finish filling those in. That's just a rounding thing, so 6.96 you could put in, 7.07 for 4, 7.18, 7.29. We can look at this multiple ways of inputting the exact same data. Algebraically, so here we need to answer the question, when does it exceed 7 million? At what point did it cross over? Well, in the third year. Between the third and the fourth year is when it finally crossed over. If we want to know that point exactly, we could go to our graph, and we know it's going to be happening at least 3, so we could trace it. And we want to trace at least 3, so I could type in 3. And see, there's 6.96. If I went a little bit farther, 3.08, 3.19, 3.29, and at 3.4, so at the third year in 4/10 of a year is when it would go to 7. So somewhere between 3.3 and 3.4 is where it's going to exceed 7 million, and 3.3 is fine. To show the work algebraically is using our equation, we would just substitute in numbers. So I would substitute in 3, I would substitute in 4, I would substitute in 3.3 and try to see if I can find that. What we call this is the gnaw process. This is something you're going to become very, very, very familiar with. You need to be able to look at a piece of information, be able to look at it graphically. Here's graphically. You need to be able to look at it numerically. You need to be able to look at it numerically. Numerically is with the table, so second graph. There's our table. Those are numeric values. Algebraically, that's our actual equation that was given to us. And then we have it in words. And the words is after 3.3 years, it superseded the 7 million. This gnaw process is something you're going to be able to do in and out, forwards, backwards, in every direction. We have to be able to use all methods to be able to look at different types of problems. Alright, you should have been able to fill in the Pythagorean theorem and the distance formula from page 5. Graphing the points to find the distance, find the exact answer. Exact means in square roots, not rounded decimals. Your midpoint formula and being able to use your midpoint is on page 7. You should be able to do the first example on the midpoint. This second one, however, on the midpoint, you might need a little bit of guidance with. So let's go over that one. First of all, let's just look at kind of what the picture represents. If this line segment AB has a midpoint of 3, -4. So when I look at that picture, here's 3, here's -4. That's the midpoint where the endpoint of A is -3, -1, and I want to know where is B. Well, if this is the midpoint, it means B must be somewhere down there. That just gives me a visual. That just gives me a graphical representation. So we're going to work out algebraically. Well, algebraically says if I add my two endpoints of x, -3, and divide by 2, I get the midpoint. And then if I add the two endpoints of y, so that's the by endpoint, and I add the a endpoint, which happens to be -3, it has to be the midpoint. So now it's just an algebraically solve, multiply out the 2, and we're going to get 9. Here we're going to get y minus 3 is -8. So y is add 3, we get -5. So the point should be 9, -5. And if I look up here at my graphic representation, if I go out 9 and I go down -5, yeah, that's a logical representation of our answer that we would need. So when you're given a midpoint, we set it equal to the midpoint and find the other missing end point. Alright, you were given the equation of a circle you can find on page 8. So for example, number 3 here, where the point 3,4 lies on a circle whose center is at 1, -2, find the equation of a circle. First of all, again, let's look at this kind of graphically. Here's the point 3,4, and it's on the circle whose center is at 1, -2. So if this is my center, and this is part of my circle, something, to that effect, we want to find the equation. Well, you found that the center is your h and k because of your equation that you found on page 8. What you don't know is the radius. So you have to find the radius by finding the distance. And we know our distance formula because from the previous pages. The distance from the center to any point is the radius. So it's 3 minus 1 squared plus 4 plus 2 squared. And we get that it is the square root of 40 is the distance, which is also the radius. The formula then says y minus, x, not y, x minus h squared plus y minus k squared, so minus a minus is the 2, and then radius squared. So if r is square root of 40, then r squared is just 40. And that's your equation of your circle. Alright, on page 4, we're going to hold off on page 4 because we're actually going to be working on this in class a little bit more. Alright, so that will take care of P1.